The last of the fats that we're going to talk about, we've talked about saturated fatty acids and unsaturated fatty acids, we've spoken of prostaglandins, we've talked about triglycerides and phospholipids. Now we're going to talk about steroids. Now, the context that all of us have heard that word steroid is we've heard of something called steroid hormones. Now, first, what are hormones? At the bottom of the page on D3, hormones are the name for chemicals that are secreted into our bloodstream, that circulate in our bloodstream and affect changes in our body. So they cause changes in our body's activity. There are different categories, different types of hormones. The hormones fall into two major categories, steroid hormones and protein hormones. So right now we're going to talk about steroid hormones, and then either later today or next time we're going to talk about protein hormones. Now, steroid hormones are actually made from cholesterol, and I wrote that right here. So steroid hormones, and we've all heard that term, steroid hormones, are made from cholesterol. Now, all of us have heard the word cholesterol. It's just that, again, we probably don't know what it is. So cholesterol in and of itself is not bad. In fact, we cannot live without it because all steroid hormones are manufactured or synthesized by cells from cholesterol, this fat. Now, where do we get cholesterol? Cholesterol is in our food, and specifically, it is in any food from an animal. Anything from an animal contains cholesterol. So, meat contains cholesterol. Fish contains cholesterol, anything from an animal. Eggs contain cholesterol because they're from a chicken, right? Milk contains cholesterol because it's from a cow. But there is no cholesterol in anything from a plant. There's no cholesterol in grains or fruits or vegetables. In addition to there being cholesterol in our foods, we wrote that that cholesterol can be synthesized. It can be made from saturated fatty acids, and I wrote in the word liver. Our liver, that largest organ in our body, is a giant biochemical factory, and it can actually convert saturated fats in our food into cholesterol. So, for most of us, cholesterol is fine. We don't have high amounts of it. And we use that cholesterol to make steroid hormones. But we know that people can have too much of even a good thing. If you need sugar for energy, but too much sugar, having more sugar than you should have in your bloodstream is called diabetes. You can't live without salt. We all need salt in order to live. And yet, excessive amounts of salt, too much, can contribute to high blood pressure. Well, saturated fats and cholesterol are needed. Cholesterol is used to make steroid hormones, but having excessively high amounts of cholesterol contributes to the clogging up of our arteries with saturated fats and cholesterol. That condition, which we've talked about previously, is called atherosclerosis. So too much of even a good thing is bad. So for people who have high levels of cholesterol in their body, so the doctors tell them, look, you got to reduce your intake of foods containing cholesterol. And incidentally, which common food has the highest amount of cholesterol of all common foods? Eggs. Eggs. Which part of the egg? The yolk. Now, this actually helps prove my point that cholesterol in and of itself is not bad. It's just too much of it is bad. Because the purpose of a yolk is that the yolk contains all the nutrients needed to build a chicken. That's what the purpose of a yolk is. It's got all the nutrients needed to make a little chicken grow inside of an eggshell. All right? But so if cholesterol was so bad, why would God have put so much cholesterol inside the egg yolk? The answer is you can't build a chicken without it. But if you have too much cholesterol in your body, then you got to reduce your intake of foods containing cholesterol. You also have to reduce your intake of foods containing saturated fats. Incidentally, both cholesterol and saturated fats come primarily from animals, right? There's no cholesterol in plants, and there's very low levels of saturated fats in plants as well. We did write that cholesterol is used to make steroid hormones. Let's take a look at what cholesterol looks like. All the chemicals that are shown in D12 are steroid hormones with one exception. So these are steroid hormones, these are steroid hormones. In the third row, the only one of these chemicals that are shown on this page, D12, that's not a hormone, is on the third row on the right, that's cholesterol. Let's just look at cholesterol. Cholesterol is it looks like a somewhat complicated molecule, an organic molecule. All it is really is just chains of carbon atoms with hydrogens attached, and it's looped into about 5 rings. Now, I want to remind you something. Remember a saturated fat? A saturated fat just looks like this, just a long chain of carbon atoms with hydrogens attached. This is basically what a saturated fat looks like. We talked about them previously. So, interestingly, what our liver can do is our liver can take these long chains of carbon atoms with hydrogens attached and simply loop them into a ring shape. So it just loops them into a ring shape, and it joins them together. These are just chains of carbon atoms with hydrogens attached, and it just loops them into a ring shape, and that's called cholesterol. Now, as we've seen in the case of sugars, once we understand the basic structure, and we know the rule, coming off every carbon atom are 4 lines, right? So basically, so that we don't have to draw every single carbon and hydrogen atom, on all these other molecules on this page, they just skipped drawing all the carbons and hydrogens. All right? But these are all made from cholesterol. These are steroid hormones, and they are made from cholesterol. So in all these hormones on this page, they just left off all the carbons and hydrogens. Now, just to show you 2 examples of steroid hormones, here's a steroid hormone on the third row on your left. It's testosterone. Testosterone is the male sex hormone. It's called testosterone because it's produced in the testes of a guy. All right? Right below it is estrogen. Estrogen is the female sex hormone. It is the female sex hormone. Estrogen is produced in the ovaries of a woman. Now, the thing that I'd like to draw your attention to is this. When you look at this and you look at this, they look almost identical. In fact, this is one of the main differences between them. I'm not asking you to remember this, but this right attached to a carbon here is a double bonded oxygen, and attached to a carbon here is an OH. I'm not asking you to remember that. But the point I'm trying to make is just a slight difference in the chemical structure of that molecule creates a profoundly different effect on the body. There's a big difference in the effect of testosterone versus estrogen on the human body. So it is these very slight differences in structure that create all these differences in effect. Just to look at these hormones, in the first row, it shows hormones that I'm not even going to talk about in this class called mineralocorticoids. In the second row, it shows, other steroid hormones called glucocorticoids. I am going to tell you a little bit about those. And they include cortisol and cortisone. I'm going to explain more about these in a second. In the third row, it shows testosterone and something called adrenal androgen. These testosterone and adrenal androgen are called androgenic hormones. Andro means male or masculinizing. So these are both masculinizing hormones. They create maleness, as it were. All right? We'll have more to say about both of those in a moment. In the bottom row, it shows 2 female sex hormones, estrogen and progesterone. I'm going to tell you about those. And then on the bottom right is another steroid hormone. It's listed as vitamin D. But you'll notice that its chemical structure looks pretty similar to these others. And it's made from cholesterol, so it's actually another steroid hormone. So let's talk a little bit about some of these steroid hormones. There are hundreds of them in our body. We're just going to talk about a few. So on page A11, So we mentioned, let's speak very briefly in terms of cholesterol on A11. So we now know that cholesterol is essential in our diet, just we don't want to have too much of it. Which foods contain cholesterol? So we mentioned earlier today that cholesterol is found only in animals. There is no cholesterol in plants. So you don't get cholesterol by eating vegetables, fruit, or grains. But anything from an animal has cholesterol. So you get cholesterol in meat, cholesterol in fish, cholesterol in eggs. You'd say, why eggs? Because eggs come from an animal. Cholesterol in milk. You'd say, why milk? Because milk comes from an animal. Your liver has biochemical processes where it can hydrogenate the unsaturated fat, turning into a saturated fat, and then it takes this long chain of carbon atoms with hydrogens and folds it into that ring structure called a steroid shape, or cholesterol. So our liver can form cholesterol even from unsaturated fats. Okay? It turns unsaturated fats into saturated and saturated fats into cholesterol. So because of that, we had said earlier today the most prescribed drug in the United States is what? Lipitor, atorvastatin. What does it do? How does it work? How does it lower your cholesterol levels? So we wrote, the way that Lipitor and other statin drugs work is they inhibit an enzyme that converts saturated fats into cholesterol. That's how it works. So by interfering with that enzyme in the liver that is capable of converting saturated fats into cholesterol, it lowers the total amount of cholesterol in our body. So doctors still want people to try to reduce those foods that contain cholesterol, but even sometimes people who do that, do you know of anybody who actually eats right and still has high cholesterol? It is possible. And the reason why, if you're wondering, how is it possible if somebody can eat right and still have high cholesterol? They chose their parents poorly. And what I mean by choosing your parents poorly is there are genetic factors. Hormones are chemicals that are carried in the bloodstream that affect the various cells of our body. And so there are steroid hormones and there are protein hormones. Right now we're talking about steroid hormones. So androgens, what does andros mean? Male, masculinizing. Testosterone is the potent masculinizing hormone secreted by the testes. Now, masculinizing or androgenic hormones have four major actions. And it's a mixture of both anabolic and catabolic. You'd say, what do you mean? So testosterone and other androgenic hormones speed up anabolic reactions. The word anabolic, which you should have learned in a biology class, means growth reactions. Here's how you've heard the term, anabolic steroids. Have you ever heard that? Anabolic steroids promote growth of muscles. Obviously, typical guys are more muscular than a typical female. We're not talking about women Olympic champions, but on average. So it promotes growth of bones, and that's why average guys are taller than women on average, and they have more muscle mass. Those are anabolic or growth processes promoted by anabolic steroid hormones. But they also promote catabolic reactions. What's the word catabolic? Catabolic is the breakdown of organic molecules for energy. Think of catastrophe. And a catastrophe thing breaks apart. So, or just think about how cats rip up everything. But in a catabolic reaction, there's the breakdown of food for energy. So guys who have testosterone have break down foods at a faster rate for energy, so they can eat more every day, right? You probably have heard that. It's not fair. Guys can eat more calories of food every day because they break down food at a faster rate. That increased release of energy results in most guys can run faster than most women. They perform at a higher level. This is why every time they want to get women playing on the same basketball team that the guys do, they get decimated because they can't perform at that same level. So I always like to point out that when women think this is like unfair because guys have that faster, quote, metabolism and they can eat more food every day, there is a cost to this. The fact that this speeds up these chemical reactions results in guys living 7 years less on average than women. So the cost of this is they don't live as long. It's like driving your car. One person's driving their car 50 miles an hour and somebody else is driving their car at 75 miles an hour. And eventually it causes wear and tear on the engine, and their car engine's not going to last as long if you drive it at a faster speed. So that's kind of what's going on in guys' bodies. So there is a cost to this increased biochemical reactions. Furthermore, for some reason, anabolic steroids like testosterone increase hair growth. The average guy is hairier, except for one place. He may not have as much hair on his head, and baldness, but everywhere else tends to be hairier, face, chest, and so on. And it also increases libido, or sex drive. So that's usually greater in guys than in women. So that's what testosterone does. Now, we mentioned adrenal androgen. It is a weaker androgenic hormone. It is found in both men and women. The women vary in how much adrenal androgen, or DHEA, dehydroepiandrosterone, they produce. And depending upon how much of this adrenal androgen that is secreted by a woman's adrenal glands, it primarily affects these two things. So it can primarily affect hair growth and libido. It doesn't so much affect those first two things. All right, the female sex hormones, estrogen is the feminizing hormone that causes the characteristic feminine features. Progesterone, we had said, literally means to prepare for pregnancy or gestation. That's what gestation means. And how does the body prepare for pregnancy? It involves a number of things that we'll be learning about in more detail, including increased growth of blood vessels in the endometrial lining of the uterus. And every month or every cycle, progesterone causes the growth of blood vessels in the endometrial lining of a woman. This is whether she gets pregnant or not. Blood vessels grow because every woman's ovaries release this progesterone hormone. If a woman gets pregnant, those blood vessels will nourish the baby. You'd say, well, what if she doesn't get pregnant? Well, if she doesn't get pregnant, then those blood vessels are shed. And they are shed out of the womb, out of the uterus, out the vaginal canal, and that loss of blood vessels and blood is called menstruation, or having a period. So if a woman is having a period, we know she didn't get pregnant. If she expected to have a period and she's not menstruating, that's the classic sign that if you're sexually active, you are pregnant, whether you have that period or not. So with that shedding of the endometrial lining. All right, mineralocorticosteroids. Now, these are steroid hormones secreted by the outer part of the adrenal gland, the so-called adrenal cortex. And they're called mineralo because they regulate mineral balance in the body, specifically sodium and potassium mineral or electrolyte levels. They are extremely important, and we're going to have a lot more to say about them. We will eventually get into what's known as the renin-angiotensin-aldosterone reflex, homeostatic reflex, very important. On page A13, the glucocorticosteroids. Now, gluco means sugar, and cortico refers to the adrenal cortex, the outer part of the adrenal gland. And it not only secretes the mineralocorticosteroids, like aldosterone, but the glucocorticosteroids, such as cortisol. And these hormones have many actions, including the fact that they raise the blood sugar level during states of stress. And we will have a lot more to say about the glucocorticosteroids. When we get to it, I'll expand upon this, but some of you may have heard these discussions where you may have heard about how stress can promote belly fat. Have you ever heard of that? And that's true. And that has to do with the release of these glucocorticosteroids like cortisol. We'll get into that. All right, the cholecalciferol. What the heck is that? So this is a steroid hormone actually made by our skin cells. There are cells in our skin that manufacture a steroid hormone from cholesterol and secrete it into the bloodstream. In order for our skin to manufacture this steroid hormone, it requires cholesterol, just like it does for all the other steroid hormones, and it also requires sunlight. So we need sunlight to convert cholesterol into this steroid hormone. Now, what does this steroid hormone do? It circulates in our bloodstream, and it is needed, it is required in order for us to absorb calcium from our digestive tract, in order to absorb calcium from our intestines. That's why it's called calciferol. Sometimes it's called cholecalciferol. Why chole? Because it's made from cholesterol. So we need it in order to absorb calcium. For example, if you had a glass of milk, milk is a good source of calcium. Drink the milk. If you've got this steroid hormone circulating in your bloodstream, you will absorb that calcium into your bloodstream. But what if you didn't have this steroid hormone, this calciferol circulating in your bloodstream? Then you would not be able to absorb the calcium into your bloodstream, and the calcium would pass out in your feces, in your stool. So you got to have this hormone to absorb milk. Now, in the 1940s, 1950s, nutritionists back then recognized, they pointed out to the government that increasingly fewer and fewer people were working or spending much time outdoors in the sun. Now, you need sunlight to form this steroid hormone in the skin. If you're in high school or elementary school, you start out like 8, 9 in the morning, you get home 2 in the afternoon or something like that. And you know, in the old days, kids, at least when they got home from school, then they'd go outside and play. You know what they do now? They play video games indoors. They don't play outside. And as adults, nobody's working outside. You know, there's not a lot of farmers out, you know, here in Los Angeles. Everybody is working on a computer terminal, as we said before. Nurses are spending a 12-hour shift inside of a hospital. And some people, of course, even live in worse climates than we do, where they can't spend a lot of time outdoors. It's either way too hot and sunny or too cold much of the year. So anyhow, it's believed that we weren't making enough of this steroid hormone, so they decided, they got approved by the U.S. Department of Agriculture to start putting this steroid hormone in milk. The problem is this: if you tell people they put a steroid hormone in the milk, is anybody going to drink that milk or give that to their kids to drink? No. And you say, well, they put steroid hormones in the milk. I'm not going to give my kids that. So instead of calling it calciferol, they called it vitamin D. And you can look at all the milk you buy. It says contains vitamin. It says D3. Take a look at it. It says D3. So it said vitamin D. Oh, it's got vitamin D in the milk? Yes, they put vitamin D in. I love that stuff. I love vitamin D. Which brand's got the most? So in other words, it's very interesting the words we use, because everybody agrees they put a chemical in the milk. But if they called it a steroid hormone, which is what it really is, nobody would drink it. But if they call it a vitamin, people love it. But that's what it is. So why did they put it in milk? Because milk is commonly given to children as a good source of calcium, and that puts the steroid hormone in the milk, and that way you can absorb the calcium.